In this tutorial, I will show you how to use Excel to do the Holt-Winter technique for forecasting trended and seasonal data. Here I have the gap sales data from March 1985 until March 2007. Let's first visualize the data. Here on the screen you can see the graph of the sales data. When you look at the graph, we can see there is a continuous trend going upwards, and we can see there are ups and downs that repeat every 4 quarters. If we just use the Holt's method here, we would forecast sales numbers on the trend line. So let's say you forecast sales here by using Holt's method, because Holt's method only utilized from the trend line to forecast sales. The trend line might forecast Q1 sales very close, but when it comes to Q4, as you realize that it will underestimate the sales. Instead, if we use Holt-Winter techniques, that will capture both trend and seasonality and estimate both the seasonality and the trend of this data. So let's see how we can do Winter's method with 4 quarters or 4 seasonal indices in the following workbook. To get started, we have to have initial numbers for the level, trend, and seasonality. So as you realize, Winter's method has 3 components. The first one is the level forecast, the second one is the trend, and the third one is seasonality. So we have to have initial numbers for the level, which is forecast level, trend, and seasonality. We are going to use the first 4 periods to initiate our data. That's I'm going to just take the average of first 4 periods of actual sales, and I'm going to find this average right here, seasonal average. The average of 4 periods comes out to be 161,833, and I will use this number to estimate seasonality index for the first 4 periods. To do so, I'm going to divide actual sales in period 1 by our average over the 4 periods. Actual sales in period 1 divided by seasonal average. And I will do that for the second season or Q2, actual sales in Q2 divided by seasonal average. And I will do for third quarter, and then I will do that for the fourth quarter. Now we have found the seasonality indices, which are 0.65, 0.74, 1.12, and 1.48 for 4 quarters. Let's try to understand what 0.65 stands for. Basically, the sales in Q1 or March 1985 is 35% lower than the average sales in a year. As you realize, March 1985 is a low sales season. The second quarter sales are 26% lower than average sales. On the other hand, the third quarter sales are 12% higher than average. It's a high sales season. And fourth quarter is 48% higher. As you realize, the highest sales are always in Q4 and lowest are in Q1. Next, we need the initial value for the forecast without trend and seasonality. Just for lack of a better option, I'm going to use the average of first 4 periods as the March forecast or level, which I have never estimated. And I will use number 3 for the trend estimate. I choose 3 since the first period trend will be 0, second will be 1, third will be 2, and fourth will be 3. I want you to understand one important point here. I guess initial values for the numbers I have not estimated. However, for the estimates of level, trend, and seasonality in the following periods, we have to apply 3 different formulas to get estimates. We start with our estimate for the level. We have 3 smoothing constants here. Alpha is for the level, beta is for the trend, and gamma is for the seasonality. Just be careful, I randomly assign these numbers. We will learn at the end of this video how to find optimal constants for the data given using Excel solver. Let's check the formula for the level. In the formula, I fix the alpha so that when I copy down the formula, the alpha is always the same number. In addition to that, if we want to adjust for alpha, we can just adjust the cell, and this adjustment carries over to all calculations. So level is equal to alpha times sales at time t. We are in period 5 or March 1986. Therefore, I'm going to use actual sales in March 1986 divided by our seasonality index estimate in period t minus p. So we know our season is 4 periods long. Therefore, p is going to be 4. And we are in period 5. 1, 2, 3, 4, 5. So 5 minus 4 equals 1. You might think this as, since we are forecasting the data for the first quarter, we will use the first quarter's seasonal index of the previous year, plus 1 minus alpha, also I fixed that cell, times level at period t minus 1, which is the last period's forecast of 161,833, we just estimated, plus the trend at t minus 1, which is the last period's trend estimate of 3, we just guessed. This is all we need to do to calculate level. Trend is calculated by taking our coefficient beta times level forecast in this period minus level forecast in the last period, which is 186,753 minus 161,833, plus 1 minus beta multiplied with a prior trend estimate of 3. That's all we need to do to calculate trends. Next, we are going to update of the seasonality index that is calculated by our coefficient gamma times actual sales in this period, I have some parentheses here, divided by level forecast in this period, plus 1 minus gamma multiplied by the estimate for seasonality at t minus p, t equals 5, in this case p is 4, so we take our first seasonal index estimate, which is 0.65. So you might think that since we are forecasting a sales number for the first quarter, I should use the seasonal index that we have found for the first quarter of the previous year. This is all we need to do to calculate the update of the seasonality index. Next, what we will do is we will put together our forecast. Now our forecast at time t plus m depends on this coefficient m, and m is how many periods ahead we forecast. In this case, we are going to keep m equal to 1, so we are forecasting for 1 period ahead. Therefore, since we are forecasting FITS t plus 1, we will use the level at time t, which is 161,833. We have to go back 1 period. Then we add m, which is 1 times the trend at t, and trend at t is 3. This sum is multiplied with the seasonality index of quarter 1 of the previous year. So that is our forecast including trend and seasonality. In fact, we need previous period initial values to update the trend. However, we have to go through 1 full season of initial values to update the seasonality index. Let's check our graph. Here the blue line is the actual data, and the orange line is the forecast that we find using Winters method. Our forecast matches the actual sales quite well. I mean, it follows the general trends. However, we can still improve on this forecast by adjusting alpha, beta, and gamma. As you remember, we assigned random values to alpha, beta, and gamma. In this case, the best way to adjust these smoothing constants, we will use Excel solver. And I will show you real quick how to use solver. I just copy here all the formulas that I have calculated in the previous workbook. Then I have calculated errors, and then I have calculated squared errors, and then I found mean square error. Then I calculated the root mean square error. Here the root mean square error is 232,139. And I use alpha 0.3, beta 0.3, and gamma 0.3. Now I will show you how to use solver to find the optimal constants that in fact minimizes the root mean square error. So you click here data, and you see here solver. Click on solver tab. Solver is going to ask you to set an objective function. In this case, my objective is to minimize root mean square error. Here the idea is simple. We want to make the minimum error by changing the constants. So we pick root mean square error. But if you want, you can pick any other error statistics that you want. Since we use in our assignments root mean square error, I prefer to use root mean square error for this example as well. I want to minimize root mean square error by changing the variable cells from M4 to M6. These are the cells that in fact have the random values for alpha, beta, and gamma. So here there's alpha, beta, and gamma subject to the constraints that each one of these is not smaller than 0 and is not bigger than 1. Because I don't want the computer to find alpha, beta, gamma that is greater than 1 or smaller than 0. After I enter the constraints, I hit solve. Then the computer is going to ask us to keep solver solution. Here you will click OK. As you have noticed here, computer calculates a different alpha, beta, and gamma values than the initial ones we pick. And these are the alpha, beta, gamma values that minimizes the root mean square error. As you remember, the root mean square error was 200,000 something before. Now it drops down to 118,476. So solver finds the minimum lowest error as possible given the constraints that we have chosen. Next, I'm going to copy down this alpha, beta, and gamma here. Now, as you see, our forecast is going to adjust to the new alpha, beta, and gamma. And finally, I'm going to explain today how we can forecast out of sample using Winters technique. So, out of sample forecast is the future period forecast where we don't have actual sales data. For your project, you need to forecast sales data for a period that you don't have the actual sales. So what we are going to do here that we are going to use a similar equation that's shown on the screen. Ft represents the level forecast, M is a constant, T is the trend forecast, and S represents the seasonal index. Let's say we want to forecast June 2007. Here, since we are forecasting one period ahead, M is going to be 1. And I'm going to use level forecast of March 2007 and trend forecast of March 2007. I'm using the seasonal index of June 2006 or second quarter of 2006. The reason is simple. I'm forecasting June 2007 or second quarter of 2007. So the best seasonal index that I can use is second quarter of 2006. One important point here is that, as you have noticed, I fixed the values of level forecast and trend forecast. That means I'm going to refer to the level and trend forecast for all future period forecasts. Let's see here. Now we want to forecast September 2007. So I'm going to use seasonal index of September 2006. I'm still using level forecast of March 2007 and trend forecast of March 2007. And here I use M as 2 because now we are forecasting 2 period ahead. Let's forecast December 2007. Here, as you have noticed, M is equal to 3, and I'm referring to March 2007 level forecast and trend 2007 trend forecast. And now I'm using the seasonal index of the fourth quarter of 2006 or December 2006. So finally, let's check one more data here. Here I'm going to use M as 6 because now I'm forecasting 6 periods ahead. Let's count on 1, 2, 3, 4, 5, and 6. I'm referring to level forecast March 2007 and trend forecast March 2007. And here the seasonal index I'm going to use is third quarter of 2006 or September 2006. because I'm forecasting the third quarter of 2008 or September of 2008. So that completes our winter forecast.